Get all my stuff ready here. Thank you. My name is Mark, NU6X. I'm from beautiful Sedona, Arizona, which is almost as beautiful as it is here in Jonesboro, Tennessee. First of all, I want to thank Nick Tusa, K5EF, and Diane, Westshom's daughter, for making all of this possible. Also, I'd like to thank Joseph, WA5EIJ, for helping me. I'm not sure what Joseph is. He helped me secure some of the parts to be able to build this device, and we'll talk a little bit about it. And this will be only about a 10-15 minute. We'll keep this thing. We'll keep this short. I'm just going to put a little timer on here, so I don't get talking too long. It'll buzz at me. And there we go. Okay, first of all, this is October, November 1950. 1950. The SSB Jr. This was in GE Ham News, and this was the first sideband exciter, I think, that was within the realm of possibility for our average hams to be able to build. 1950. This was designed by Bob Norgaard, W2KUJ. He was an engineer for General Electronics, and he published this again in the 1950 GE Ham News. This design was really the basis for the Central Electronics 10A, which was built by Westshom. Obviously, they did a huge improvement solving the frequency agility issues. This was 75 meters only, 5 watts output. If you moved more than 10 kilohertz, you needed to adjust the phasing coils at the very minimum. We'll look at this a little bit. Also, it's my understanding that GE really had no interest in ham radio at the time, and they gave permission for Wes to use this design. There's some key ingredients, key components in this. I'm not going to get into the details of the mathematics of how a phasing radio really works, but there's two key parts. You need to be able to get a phase shift of 90 degrees, and you need to get an RF phase shift of 90 degrees. And by adding them together in the right way, you can null one of the sidebands. And so this is what was the unique piece right here. This was a phase shift unit designed by Bob Norgaard, and this is almost identical to the PS1 that's in the 10A, 10B, and 20A. Not only was it in the 10A and Central Electronics, but Lakeshore was also using that same phase shift unit. And it looks like from some of the examples that I have, that phase shift unit was probably purchased from Central Electronics. So that discussion about how they were sharing information at that early 1951-52 time frame, clearly they were also actually sharing manufactured parts. So this was one of the key ingredients, this phase shift network. The other part of it was the RF phase shift. And to my best of my knowledge, this was probably the first time that this was done. Essentially, you have 2 tank coils, 2 tune circuits on the crystal oscillator, which is run at 75 meters at your transmit frequency. And by adjusting one of those coils below resonance and the other one above resonance, you could get a phase shift. And you get those exactly at 90 degrees. Go into a double balance modulator, you suppress the carrier, you suppress the one sideband, and you have single sideband. And it driving a single 6A G7, it would put out about 5 watts. So very simple, 3 tubes, not quite as simple as that 210 device that Bob was presenting. I'm seeing about 30 dB of opposite sideband suppression. Of course, carrier suppression, 40 dB or better. But basically 30 dB of sideband suppression. And by the way, this thing sounds wonderful. Now the audio is quite broad. You know, there's nothing in the amp circuit in the preamp in the mic circuit that's going to limit the audio, and so it's only limited by the receiver at the other end and of the microphone itself. Just to show a few pictures of this, just a couple notes. A couple of the parts to get, which I got some help from Joseph from, is I used the exact mill and coil forms that they recommended. I don't know how critical that is, but just to make sure, that's what I did when I built this unit, and especially these two coils, the separation, because they're coupled between the two, and so that's pretty critical. I think it's 1 1/8 or 1 1/16, so that separation is very critical. The article talks about using the exact transformers that are specified. Those still are available from time to time. Find them on eBay all the time. This is the R38s. And then I forget what this one is, A53 or something. A53C. So you put a search on eBay, those show up. They've gotten a little expensive, but it's possible that other transformers may be able to be used and it might work just as well. There's a couple of these that are in process of being built. Another one, Nick helped get some of the parts for K6ZSR out in Santa Barbara. He's in the process of building one, and I'll show you a few pictures. And Joseph is also in the process of building one. And so if there's anybody out there who also wants to build one, we'll give you all the help that you could ask for. Try to help you get the parts, and love to be able to get more of these on the air. Just to show some pictures. By the way, this is the unit. Try not to drop it. I tried to follow the original. Layout. These are the actual coil forms, the tuning slugs. Mic gain up here. I made a couple minor changes from the original layout, but not much. Here's your carrier balance. Another picture of it. This is from it looking upside down. These are the two R38 transformers here, and then this is the A53C, and then the coil forms. Another shot of it. Now, I cheated. The audio phase shift unit that was in the article is identical to what the PS1 is today. Okay? So instead of going through all that and building my own PS1 or my own audio phase shift unit, I took one out of parts 10A or 10B, took the can off of it, put a little 9-pin, and I did not touch this. I didn't have to adjust this one little bit. That's how good, here we are 60, 65 years later, and we're still getting absolutely very good 90-degree audio shift. So that's what that unit is, and this is the position, if you were to home brew that phase shift unit, that's where you would put it.
Hey, Mark?
Yes?
Do the capacitors in those phase shift networks not turn into junk by now?
Evidently not. No? All I can tell you is I'm getting 30 dB of suppression, opposite sideband suppression, and I wouldn't be able to get that if that, and I didn't touch the, Joseph.
Nick Cruiser told me that he has never seen the bad PS1.
They never do though, man. Those are mica and criminal.
Yeah. So Yeah. Exactly. So, if you want to build one of these are floating around. We can probably find a few. And so, and that really makes the project very easy. When I completed wiring this and I put power to it, within 10 minutes I had it putting out full power, 5 watts, with 30 dB of suppression. It was that easy. And again, that's a 1950 circuit. key point on this again is that Westrom took this idea, generated the sideband at 9 megahertz, and then started mixing it up and down so that he could move it to all the different amateur bands. And the idea here was that that 9 megahertz was fixed, and so once you get it adjusted for good sideband suppression on 9 megahertz, you could go all over the ham bands without any issues. Just one last thing, if I can find it. If I can see. Let's just go to this one real quick. This was originally designed for a carbon microphone. Now this thing sounds absolutely wonderful using a nice modern microphone, but you got to get the gain up pretty high. You know, it needs a couple volts, 3 volts or so of peak of audio to be able to drive this with this particular circuit that they originally designed. So this is a carbon microphone, and requires a couple batteries and a transformer. And so I've had this on the air with this microphone. Doesn't sound as good as the new modern microphones. But I learned a trick that I didn't know. When I first put this microphone on the air, it sounded good. And then it started sounding really bad. And people were giving me a... Well, you see, all you guys know the trick, and I didn't know the trick. You know, finally, halfway through our vintage sideband roundtable, they said, "Mark, Mark," and then I started sounding good again. So, you know, you guys are all a lot smarter than I am. So anyway, one last thing, we have another ham who is working on one of these. Both Nick and Joseph has helped them get parts for my K6 ZSR, my good friend in Santa Barbara. So this is his. I don't know if that's showing up very well. He's being a little bit more original. He's using cloth wound wire to match the time. He's using the original type capacitor that was in there. That's the front panel of what he's doing. And there's the top. This is in construction. And hopefully in the next few months he'll have this up on the air as well. And again, both Nick supplied him the PS1 unit for the audio phase shift unit, and then Joseph helped him get the coils. So basically that's my presentation. That's all I really want to say. This will be on the table, and anybody has any questions of what I'd like to look at it, feel free to contact me. So thank you so much.